So yesterday, okay, so today we are going to discuss the different functional form. Why this is very important, I am telling you, because you will find applications for this actually coming in microeconomics. I have checked the question paper thoroughly. It is coming in also macro also, some applications, and also econometrics, statistics and econometrics section. So it is a like overall discussion for many questions. I think saving function questions. Then some other questions are related, directly related to also the basic discussion which we will be doing over here. So that is why we thought that slope and elasticity calculations for different forms of equations, basically regression equations or type of econometric model we will be discussing. And this is how it will be basic calculus. I have already sent you, and Madhusmita, you have said your solution. I think other solution I have not received so far. So Ajay and Sangeeta, please send your solutions as well. Okay?
Okay, sir.
Yeah.
I'm
Okay,
just
sir.
Yes.
Sir,
Yes.
my solution is correct or wrong?
No, I will check after the class.
Okay, sir. Okay, sir.
Yes. Yes. After the class, I will check. Because now onwards, I will give you a small assignment also. Okay?
Yes.
Just to check where you are. And moreover, this week also we are going to have the next test series. Okay, test series will be on which section? It will be on because already we have discussed linear regression model, many things, right? So I will be discussing. I will club this. I'll do 100 questions. Okay, 100 questions. I'll club it. Okay, 100 questions.
Sir, probability question conditional probability will also come, sir?
No. Conditional probability will not come, but I will pick up the conditional probability again, once again, in detail, little
Okay,
after
sir.
1 or 2 classes. Okay, but
Okay, sir.
this test will be there on statistical inference, hypothesis testing,
Yes, sir.
linear regression
Okay, sir.
model and their properties, because large chunk of questions are coming from these sections only.
Yes, sir. Yes, sir.
Okay, so at least 40% of the questions are coming from this section. So I am going to set that. Then I'll do a quick review because because we are having very less time. So one theory review will be also there for identification problem, simultaneous equation model, discrete choice analysis. What are the different type of model? It will be like a quick recap, and we'll be discussing the numerical directly straight away from the previous year questions, so that we can cover these sections also when we are discussing those questions. Okay, so that then in together, then unit 3 we will be completing. Okay, so that was my plan. So we'll go for today's session. So first is basic calculus. I think Ajay is teaching this time, so he is familiar. Madhusmita is familiar. So I will share a book with you, all of you. That this book, Sangeeta, Elements of Mathematics for Economics and Finance. So this book
Okay,
I will
sir.
be sharing. This is a very easier book. Okay, and this will help you also in this section where mathematical economics section. Even though you are
Okay,
not
sir.
targeting, not a problem.
Yes, sir.
But basic whenever after the exam or even if right now also you can, I will tell you few sections you have to just quickly see if you are able to understand or not. Then what I will
Okay,
do
sir.
is after your exam will get over, you all have to solve one chapter every day. Okay,
Okay, sir.
because mathematical skill is very important. Even though
Yes, sir.
who is weak, who is strong, it doesn't matter. Okay, so
Yes, sir.
after that, I will ask you to solve one chapter like at least in a week, at least, and I will check your notebooks also. Okay, so that because
Okay,
otherwise,
sir.
otherwise my efforts will be not actually counted anywhere. Okay,
Not that
Okay,
possible.
sir.
so that is why if math is there means statistics and econometrics will automatically come. Okay, if math is not there, I cannot say that I have helped you, or you will not able to say that also you have learned anything. Okay, so let's be very particular about it. So now going forward, already you know derivative of a constant, right? All of you know. So it is 0. So there is nothing to know over here. This is also, I think all of you know it, right? So is there any problem in understanding the basic rule over here? I don't think.
No,
Right?
sir.
No,
So,
sir.
okay, good. So I'll quickly go like little faster. This is multiple, you can say constant when it is multiplied with a functions. Okay, so this is also straightforward, so there is no problem over here. Sum and difference rule is also fine. Which is very important to us is derivative of the natural logarithmic. So this formula is also quite easier to remember. So that is what which is going to be used. Rule number 6 is actually very important for us. If there is a chain rule kind of differentiation which you are going to do, so you have to remember that there are actually two functions which are nested in between in y when you are trying to differentiate with respect to x. So you are supposed to calculate dy upon du, because we are saying that y is a function of f of u is a function of g of x. Okay, so dy upon du into du upon dx. Then we are able to differentiate y. Correct? Now, for example, in this question, so your y is ln 2x. So there are two functions over here. First, you are saying that ln u with respect to u into d2x with respect to dx, because we are taking that we are counting that 2x is equal to u. So now if we will differentiate, it will be 1 upon u straight away into 2, so it will be 1 by x. 2 get cancelled out, so it will be 1 by x. Now coming back to elasticity already we know that.
Sir, I have one doubt, sir.
Yeah.
Sir, in this chain rule, how we are deciding that if we will take u is equal to 2x and y is equal to ln 2x, sir?
No, it will go in your mind actually. Okay. Like if you will be differentiating, you should know that ln 2x log is there, because already we know that if y is equal to ln x, so what is the formula already we know, right? Now by looking at the function you should be able to understand, and there is
Okay, sir.
no, like if you will think that it is not you are not going to apply the chain rule over here, then if you will
Mhm.
solve in any other method, I think you are going to like get error. Ajay, what is your take? Because you are teaching
Okay, sir.
mathematical economics. Let Ajay to answer. Okay, let's see. Sangita has
Sir,
asked a good question.
okay, sir. Sir, in the questions will be like 5x plus 2x square ऐसे होगा. So we can take u as x 5x plus 2
Uh-huh.
ऐसे
No,
लेके
no, no, no. Don't change the answer question.
okay,
You,
sir.
in this context, you tell what Sangita asked, that how we will think that.
Identify,
Uh, so
if any function is given,
uh,
so that we will take a factor, or basically a which will be basically a functions as suppose u, let u that u equal to these functions, then we can differentiate that functions.
Okay. I think Sangeeta, to
Sir,
yeah, Madhusida, you want to say something? Okay.
actually, sir, in the section of when we solve the RSS in the derivation format, you mentioned that the chain rule is derived from the composite function.
Yeah, composite function.
Yes, sir. So a composite function is created when one function is substituted into another function.
Yes. That is what I told, na? Nested.
Yes,
Nested
sir.
means that is basically what you are saying. Yeah. Hmm. Hmm. Yeah, go on. Go on.
So for the simple calculation, if we take y is equal to function of u and we substitute u is equal to gx, then we are able to calculate in the better way.
Okay. And Sangeeta, my take will be already
Yes, sir.
Madhusmita and Ajay, they have already told their view on that. I agree also, but for that you have to read this book. I will give you which chapter you have to read. Okay, at least
Okay,
one
sir.
page document
Okay,
is
sir.
there. You read, and then if you are having doubt, then we'll discuss, because
Okay, sir.
I have to
Okay, sir.
discuss in detail. Otherwise,
Yes, sir.
uh, but for me, here it is clear, because you can see ln in bracket it is written 2x. So clearly you are able to see that there are two functions over here, because usually we write like y is equal to ln x in this way. But here, if it will be written also, it is fine. But here it is already written like this. So that is why. So you have to differentiate two times over here, like shortcut method. Maybe some mathematician will not agree, or we are not going in that way. I am just telling you some rough way to answer your query.
Okay, sir.
Okay.
Okay,
Now,
sir.
now going forward, elasticity questions. If as a student of economics, I see that if anyone by mistake also you are forgetting, then it is a blunder. So, because elasticity question are coming in your production function, I have checked frequently. It is coming also in econometrics also. So my take will be, please don't commit any error. If you are having any problem or any with respect to calculation, the formula, again I will be referring, I will give you some document, please read it. Okay? The formula, if you
Yes,
are,
sir.
हाँ,
It is very, very crucial for in international economics as well. We are using the elasticity method.
elasticity, very good. Thank you, Ajay. So Ajay has also told. So this is also applied, and there are many questions. I think Ajay has appeared last time also, right? So you will find at least one or two questions in any discipline, any unit, right?
Yes, sir. Definitely. Elasticity is very, very important.
Yes. So elasticity, first of all, there are two formulas. One is without using derivative, we used to do in the class also. But if you are going to use derivative, it will be much easier. That is the whole point. Because we are not going to write it, because suppose let's say that what is percentage change in y. We have to write like we might have taught like this in the class. So delta x by x. So it will be delta y by y into, it will go to the numerator, so it will be x by delta x. So same thing it is written over here. It means if you will rearrange, it will be delta y upon delta x into x upon y. So it is better just you take the first order derivative of a function and then you multiply x upon y. Is it clear, Sangeeta? Chinmay, is it clear? Okay.
Yes, sir.
Okay, thanks. So now we'll go move to linear model. First of all, Sangeeta, are you there?
Yes, sir.
Why this model is called linear?
Because the value of the parameter is
What
1, sir.
what are the parameters here?
Sir, beta 1 and beta 2.
Okay, very good. So this is the simplest model. Actually, first of all, linear function also it is. You will see that it is coming in macroeconomics also questions. So linear functions. Can anyone tell me some of the properties? Basic property of a linear function. Madhusmita?
Sir, basically the linear function degree is 1 and
Don't make it complex because you might have seen you are teaching macro.
yes, yes.
We use where consumption function, saving function. Everywhere you will see that it is a linear function.
Linear function, yes, sir, is consumption.
Like just I have given few only. There are like thousands of examples are there in macroeconomics where they use like ISLM, everything. I can show it in terms of linear function. Now you have to tell me what is something very unique in linear function. So this is A minus BP. This is demand function which is a linear function. You just see the slope is constant over here.
Yes, sir. The slope is always constant.
Slope is always constant.
Constant.
For each unit change in x. It means basically it is saying that where y change by a constant amount means the delta amount. And that is the slope basically. Because we have already calculated the beta 2. Beta 2 is nothing but in terms of interpretation we know that it is delta y upon delta x. So that refers to what? How much delta y is changing? It is changing by beta 2 times delta x. Yes or no?
Yes, sir.
So beta 2 is the important over here. So now you have to remember that in a linear model, basically your slope is remaining constant. Again, here the units, something which is not here. If x is, let's say whatever the unit is there, and y is different units are there. So now can you tell me whether there will be any impact on the beta 2? What is your take? Means if let's say that y is GDP, now x is let's say that inflation. It might not be a perfect example, but let's say that. So the units will be different, isn't it?
Yes, sir.
Then the question is now, because this topic I have not covered in my earlier discussion with you, what is the impact of change in units? Change in measurement units on slope. Because this question, if it will come, whether you will be able to answer. For that, I will be sharing with you a document. Please go through it, direct formula, where straight away you can pick it up. Okay, how much beta 2 will change? Because in maybe if the questions will be very complex, sometimes they will confuse you also. If x changes, suppose let's say that there can be anything like in terms of rupees. If it is y is given in billion, then x is given in million. How the beta 2 will be interpreted?
Yes, sir. Beta 2 is also changed because according beta 2 is associated with that particular x value.
Yes. So that is the reason we should
Yes,
know also that. I am just telling you because we will be discussing on that as well. Okay, not today. I will just first I will give you a document where you will read and then we will discuss on that. But when you are preparing, you should be aware about it.
Yes, sir.
I think that is there in the Gujarati extension of two variable regression chapter. So those who are interested, you please read, and then I will give you a setup formula, okay, which directly will tell you the how you are going to interpret. Okay, those are like very basic questions, but they are very core questions. Like you know what is beta 2, but if you don't know what will happen if y GDP is given in trillion and x is given in some other percentage, how you are going to interpret if one question will come. Are you getting my point?
Yes, sir.
Then all of our understanding is zero. So to avoid that, so I will just make you aware so that you will remember.
Sir, are you saying about the unit of measurement? If the unit of measurement is
Yes.
changed,
Unit of
then
measurement changes. Like we'll discuss that because it is very important. Because I sometimes question if it will come, maybe you will get confused. Okay, or you will choose the wrong one. Are you getting my point? There is a high chance because the people are not actually aware about it. They think that okay, beta 2 means 1 unit change in x will lead to beta 2 times change in the y. But now this when the unit changes, the interpretation also changes, right? So then our question is little like our task gets little trickier. Okay, so for that we will be discussing in some another day. So let us first complete this one. So first you will write down the equation, then take the derivative both the side, right? First of all, this is a beta 1 plus beta 2x. So now you can apply the sum rule, rule number 4, which you have learned. So now already we know, right, the sum rule. Now because beta 1 is a constant, so it will be 0. Then you will apply the constant multiple rule over here to beta 2x. So beta 2 into dx upon dx, so that will be beta 2 in times 1. So it is beta 2. That is the reason how it is. But when we are writing, we are simply writing delta y upon delta x. Okay. Now why it is become delta y upon delta x? Why it is beta 2? Are you getting my point, Madhusita?
Yes, sir.
Usually we teach like in any class that beta 2 means delta y upon delta x.
Del X.
Now the question is, if the question is getting reverse, why delta y upon delta x is equal to beta 2? Then you have to derive everything to get here, because proof we can do anyway, na? Because if it is LHS and if it is RHS, you can prove from RHS to LHS and from LHS to RHS as well. Are you getting my point?
Yes, sir.
Then your understanding is clear. So I think this is fine. So the final result is delta y by delta x is equal to beta 2. So the interpretation is the slope is constant and it is equal to beta 2. This means y changes by beta 2 units for every 1 unit change in x. Now what I asked you that how the interpretation will change when the change in units happens either in y or in x or both y and x. So Madhusida, you just read on that and we'll discuss some other day. Okay.
Yes, sir.
Next question. So the first easiest function, already we know that elasticity will get dy by dx into x by y. So if we substitute it into beta 2 straight away, so it will be x by beta 2 times x upon y. It means for a simple linear function, you can find the elasticity as beta 2 times x upon y. Now the question is, the elasticity is not constant because it depends on the values of x and y. So different points on the line may have different elasticity. This is also very important to understand. But the slope is, that is why sometimes in the interview, are you getting my point? We ask slope and elasticity. What is the difference? Madhusmita.
Sir,
So
slope may be constant.
this is the if when
Interpret.
suppose if someone will ask you this question in the interview, you will simply write the equation and derive it and tell them that elasticity is different and slope is different. Slope will remain constant in a linear function, but elasticity may not be constant because it depends on the different values of x and y.
Why?
But if you have not understood, then you will not able to tell, na?
Yes, sir.
Okay. Is it clear, Sangeeta?
Yes, sir.
Okay, very good. Now you just see, there is a numerical example over here. If y is equal to 10 plus 2x, beta 1 is equal to 10 and beta 2 is equal to 2, then slope is dy upon dx, which is equal to 2. It means it is constant everywhere. Means the rate of change is constant. Are you getting? Now, if you will calculate elasticity at different point, then how you will calculate? Because this is your regression equation. Y on x. Then when x is equal to 5, you will be calculating y 10 plus 2 times 5, so it is 0.5. When x is equal to 10, it is 0.67. Are you getting my point? So what
Yes,
is
sir.
happening? Slope is always 2, but elasticity changes.
Changing.
But I am telling you from my experience, not a single candidate were able to tell this answer. I don't know for what reason they forget this, because usually teachers they might have taught in the class, but maybe you are not aware that it is a very basic question, but people forget. Are you getting,
Yes,
Madhusudhan?
sir. Sometimes we are also
Yes, sir.
using these two terms are interchangeably, elasticity or slope.
Because you have to remember that. That is why I asked that slope is always constant in a linear function, but elasticity will change. If you will say this sentence only, the outcome, this is also fine without writing anything on the board. But if anyone asks you, then you just take a linear function and prove it. Are you getting my point?
Yes, sir.
That is the reason why we need to understand this in detail. Otherwise, we are not able to clarify our doubt. Then the next type of model is log linear model, or it is called double log model, or it is called log model also. Like if you see the Gujarati, which chapter, Madhusita?
So chapter 5.
Chapter?
5.
No. Chapter 5 is not having this. Extension of two variable regression, that chapter. Choice of function, chapter 6. Chapter 6. Maybe your book might be, my version book is little different, but the PDF I will share with you is, because I have a little older version, very old version, but I don't think that way, so it is fine, not a problem. So going forward, so double log model. So double log model, where we use Sangeeta? We had discussed also during our question answer discussion.
Yes, sir.
Means what is the speciality of log model? Like for example, if in an interview they are asking this question, what is the speciality of log model? And where we use? Because this question is linked to your microeconomics, and statistics and econometrics. Yeah.
Sir, while considering the OLS estimation, sir, we used this log linear to transform the non-linear model and used OLS, sir.
Um, I think you took it little in different way. That is another context. But here what I am
Okay,
asking
sir.
you is why this model is popular, or what is the most attractive feature of the log model. Okay, so now the question is towards Chinmay.
Sir,
Yeah, please go on. She's having
sorry,
some
sir.
she's having some problem. So Madhusmita.
No, sir. Sir, basically log model we use in case of exponential data.
That is fine. I am telling what is the attractive. Is it very attractive feature you are talking?
No, no, sir.
Okay, Ajay.
Basically, proportional
Yeah,
measurement.
Ajay is very close. So you all have tried. So thanks for that. So basically, uh, this is a very popular model. Okay. The reason is this beta 2 is this measures elasticity. Okay, directly. Okay, suppose y is given to you, x is given to you. You don't have to calculate elasticity by applying special formula. Okay, what you have to do is you have to be tension free. Just you convert into ln y and convert x into ln x. Then you run the regression. Are you getting? Suppose if you divide and moreover, we will be tension free about the change of units in x and change in units of y if we have converted them into ln, because the percentage change interpretation will come into the picture. Are you getting? So it means beta 2, the slope coefficient beta 2 measures the elasticity of y with respect to x. That is basically the percentage change in y for a given small percentage change in x. Is it clear? Sangeeta? Sangeeta, now it is clear?
Yes, sir.
So now also, suppose for example, uh, you can say that if y represents the, let's say that y represents quantity of commodity q, then your x represents
Price.
price. It's unit price. Unit price. Okay? Not price, because in economics it should be very objective. Okay, Ajay? Unit price. Unit
Yes.
price. Unit price is more clear than price. Okay? So, because economists are very obsessed with terminology. So, you will be also one day obsessed with the terminology. So, now, so how we will interpret beta 2? You can try, someone can try. Madhusmita, you want to try? Means what is the interpretation of beta 2 over here? First, you know what is beta 2, right? It is measuring
Okay.
the elasticity of y with respect to x.
X.
And then I think Sangita also told the point that in exponential function, if you will take the logarithmic function, it will be a linear function. That is also fine. That is the application of this model. Okay. Now I am asking about the interpretation. So interpretation is like this. Because elasticity means percentage change. You have to remember. This is a keyword. So whenever elasticity is there, It means percentage change. Now you tell me, isn't it better that always, because I told you, Sangeeta, do you know like why economists are obsessed about finding the rate of change? And can you tell me the different type of rate of change?
Different type of rate of change.
Yeah.
The rate of change is calculated to study the cause and impact effect relationships, sir.
Be very precise.
Like how
Or
one
yeah, yeah. Carry on, carry on.
like how one variable is affecting the other variable, and in what ratio it is affecting.
No, no, no. Okay. Thanks. You have tried. Madhusudha,
Yes, sir.
what are the
What's
different type of change?
sir?
We
Change
and
mode is
how we
what,
calculate? How we calculate the different type of change in economics?
sir? Sir, through the variable.
No, I am asking about
Sir, like
us.
sir, increasingly changing or
Ah,
decreasing
no,
or
no,
Positive,
no,
negative,
constant
no, 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 no. It is absolute change.
relative
okay,
change.
Then
relative change.
relative or
Relative,
proportional change.
okay, sir.
Relative or
Proportional
proportional
change.
change. Then percentage change or percent growth rate. It is very clear, crystal clear. Percentage change or percent growth rate or percent growth rate. Is it clear?
Yes, sir.
Because you see, in macroeconomics we calculate GDP growth rate, we calculate inflation growth rate. Everywhere we calculate growth rate, isn't it?
Yes,
So growth rate is what? Basically change over a period of time. Then the question comes next. What do you mean by change? Okay? Is it clear, Sangeeta
yes,
now?
Yes, sir.
So when we are saying change, whatever the answer you have tried, that is fine. Positive change, negative change is fine. But how will measure the change? Are you getting my point? My question was,
Yes, sir.
how will measure the rate of change?
Yes,
Okay?
sir.
And second, whenever we say change, rate of change, it is always in terms of time. Okay? So basically, in time series data, we calculate like GDP growth rate. Now the next thing is there. Always you remember, whenever the logarithmic is there, means it is relative change in x. How we will calculate then? Because if it is a time series data, suppose for example, if you will take xt and this is xt minus 1, means it is for the year 2024 and this is 2025, right? If our GDP was 100 in 2024, then this is our xt minus 1. And if it is, let's say that 110 in 2025, this is xt. Is it clear? Now, can you tell me, already I told you xt, what is xt and what is xt minus 1. Then
Yes, sir.
how we will define what is relative change? Let me ask Chinmay.
Sir, xt minus 1.
Eh? What is xt minus 1? Where I am asking what is the relative change? Relative change in x. What do you mean by relative change in x? Be very quick, Chinmay. We are having very less time. Okay. If first of all, if you are not sure about the answer, you will say that I will prefer to pass it on. Okay.
Okay, sir.
So yeah, you want to answer?
No, sir.
Okay. First of all, when we say relative change means with respect to the base year we are talking about,
Yes,
isn't
sir.
it? Because GDP growth rate we calculate like this, na? Isn't
Yes,
it?
sir. Yes, sir.
That is what I was telling you. So directly, if you convert the regression, means if you transform your variable into ln y and ln x, so you will get actually relative change that we will discuss. So this is similar to this formula. Is similar to, or it is equal to, not similar is the wrong word. So it is equal to ln xt minus ln xt minus 1. Now if you will ask, sir, how it is this, so that will, like, it is easier also. Who can tell me how I am saying this? If someone will tell, I will give a gift of a book.
Sir, a question please again, sir.
I am telling that I have written xt minus 1 upon xt minus 1 is equal to ln xt minus ln xt minus 1. Now I am asking you how this is equal to this. How this formula, is it clear? Let's say that this is LHS and this is RHS. How? Quick, Sangeeta. Or you pass it on. You want to pass it on? Wait for
Yeah.
your turn. Ajay.
Yes, sir.
You want to pass it on?
Yes, sir.
Okay, very good. So, Chinmay,
Sir, because of xt upon xt minus 1
okay, let me
equal
write
to
it.
ln xt.
Uh-huh,
Sir, xt upon xt minus 1
uh-huh. Yes. Go on.
Sir, xt upon xt minus 1 equal to ln xt and xt minus 1 upon xt minus 1 equal to ln xt minus 1.
No, suppose let's say that if I will do some algebraic treatment over here, what it is happening? xt upon xt minus 1
Minus 1
minus xt
minus
minus
xt
1 minus 1.
upon xt minus 1.
Correct. So this is 1 and this is xt upon
Ln
xt minus 1 minus 1. Now you tell me further. Now we got till here. Now from here, how we will go to here? Now I have made your life easy, na? Chinmay.
yes, sir.
Now you tell me.
Sorry, sir, I will pass it.
Okay. Sangeeta, what is the value of ln1?
0, sir.
Okay, very good. Now, if I will convert, if I will take LHS, ln xt upon xt minus 1, the whole, I will convert. So, how will convert? ln xt upon xt minus 1 minus ln 1. Isn't it? Chinmay.
Yes, sir.
So what is log m upon n formula? Quick.
Ln n. Sir, ln
ln. Okay. ln upon into m upon n formula. What is it?
sir ln n minus ln m
Very
divided
good.
by
Very good. So now ln xt minus ln xt minus 1. and this is already 0, Samgita told. Now I can easily prove, na? So this is my RHS. Yes or no?
Yes, sir.
Then why you are not able to tell? Are you getting my point? So, is it clear, Sangeeta, now?
Yes, sir.
But earlier you were saying that you didn't know, you passed the answer. But you know the answer actually.
Yes, derivation. Yes, sir.
Everyone knew the answer, but no one has thought of actually how it will be. Madhusita, you knew the answer?
Sir, actually in the derivation I have doubt.
Oh, where? Tell me.
No, sir. Now it is.
Huh? No,
Now
if you are,
doubt is clear, sir.
so Madhusita asking means there is a basic problem. So that is good. Others will understand. Clear.
Sir, can we convert every login function in like this, sir? Then we
No,
can
no,
go
no.
to derivation.
No, that is fine. No, I am asking that how relative change will be converted, how relative change formula, the basic formula, is converted to log. That is our whole point. Okay, Ajay.
Yes, sir.
So this is how you will be writing it. Is it clear? So let's not discuss. Yes, whatever you told, that is the further application. I will come to that. Okay. So now, Madhusmita, you don't have any doubt, right?
No, sir. No, sir.
So now, what you know about relative change? The relative change is close to, means relative change formula is equal to ln xt minus ln xt
ln
minus
xt
1.
minus 1.
And second, another important thing I told you, it directly, if you will take ln y, you will convert y to ln, and if you will convert x to ln, so you will get beta 2 is the direct percentage change. So it means how you will interpret. So basically you will be interpret like you can say if x increases by how much? How will you interpret the elasticity? Just now I told, na? Yes. Percentage
The
change in
percentage
y.
change in x1, oh, sorry, x, sir.
Mhm. That,
Percentage change in x
mhm.
associated
So basically
with the
beta 2 is giving the percentage change in y with respect to or for a given percentage change in x.
X.
Isn't it?
Y upon del X.
Hmm. Have you written all of you? Because you are
Yes,
forgetting
sir.
again
no,
and
sir.
again. Chinmay is forgetting.
Yes, sir.
What is the interpretation? Tell me first, Chinmay.
Sir, I don't write, sir.
Sangeeta, what you have written? Can you read it out?
Sir, I have also not written it, sir.
Okay. So please write that the percentage change in y. So beta 2 measures the percentage change in y. Let me write it so that you all will not forget. It will be there in the video also. So beta 2 refers to, or first of all, beta 2 measures the elasticity. Measures the elasticity of y with respect to x, or that is basically the percentage change in y for a given, that may be a small change also, not a problem, small percentage change in x. Okay. Is it clear?
Yes, sir.
So after this, please don't forget. Okay.
Yes, sir.
Okay. Now, as we have done the groundwork, now our job is to move on. So how will derive the slope over here? First you take the derivative similar to earlier. Okay? Clear? Is it fine? Now up to step 3, is there any problem? Chinmay, Madhusmita?
No, sir.
Okay, very good. Step number 4, you simplify each term. That is d beta 1 with respect to dx is equal to 0, constant rule. Then beta 2 ln x. Sangeeta, it is what
Sir.
kind of rule 5 is what? You have
Sir.
forgotten chain rule.
No. Yes, sir. Chain rule, sir.
Is it chain rule, Madhusindha?
No, sir.
No, sir. No,
No,
sir.
sir.
No, sir. It is log rule.
So that is why I was thinking that whether you are aware or not.
No,
It
sir.
is. This is, I told you, this is a
Log
important.
rule.
So that is why it means you are not giving attention. When this word is there, important means what? This is a standard result you should memorize, right? 1 upon
Yes, sir.
x. So now, so please remember this, okay? Rule number 5 here. So basically d ln x upon x, it will be dx will be equal to beta 2 times 1 upon x. Right? This is 5. Is there any problem over here?
No, sir.
No, sir.
Okay, very good. So now, next step, what it will be? So it will be beta 2. Basically, so now we are having d ln y upon dx is beta 2 times 1 upon x. Now you have to apply the chain rule to the left side. Okay? How it will be? Because it is ln y. I think yesterday we were having problem here, isn't it, Madhusmita?
Yes, sir.
So by chain rule, it will be d ln y. So because this is what we have to differentiate. Now, as Sangeeta had asked earlier, that how we will decide which one is u and which one is because here y is directly we can say that it is u over here. So d ln y with respect to dx we are calculating. So first we will be differentiating with respect to y, but again we have to differentiate with respect to x also. So that is why it is d ln y upon dy into dy by dx. Now what do we know? Already with the formula already we know. So it is 1 by y into dy by dx. So now hence which is equal to beta 2 times 1 by x. Is it clear? Or is there any problem? Madhusmita?
No, sir.
It's crystal clear, right? You will never forget.
Yes, sir.
From where we are getting this? Because already we had proved this.
Right.
Okay?
Yes.
Sangeeta, Chinmay,
Yes, sir.
Yes, sir.
yesterday we had some issue. So now what you will be doing? You will solve for the dy by dx by multiplying both the sides y. Okay? So to get cancel out. So this y will get cancel out, but y will be here in the right hand side. So dy by dx is equal to beta 2 into y upon x. Is it clear?
Yes, sir.
Okay. Now what is the interpretation? Dy by dx will be equal to beta 2 into y upon x. So what is this interpretation? Very important. The slope is not constant over here. It depends on both and x and y. As x increases, y increases and the slope changes. Okay, so this is the slope over here. Now we will see whether it is elasticity. What is the elasticity or not? Are you getting my point? Is it clear, Madhusmita?
Yes, sir. Yes.
How we are saying that in a log-log model it is a percentage change. Now it will be clear, this step, when we will derive the elasticity. Isn't it? Already we know the formula dy by dx into x upon y. Now if we change, already you have calculated this dy by dx, that is beta 2 into y upon x. So now this beta 2 into y upon x, already we know, just you will write it over here. So now y and x, x and x, y and x, y. So this is getting cancelled out. Now what is remaining? Beta 2 into 1, that is beta 2. Is it clear?
Yes, sir.
Then what is our conclusion? The elasticity is constant and it is equal to beta 2. This is why this model is called constant elasticity model. Is it clear now? Constant elasticity model. Correct?
Yes, sir.
But if I will ask you, because this is a very important model, if you just see, if you will confuse that, okay, this is already dy by dx means beta 2 into y upon x, so this is something like, sound like it is a elasticity, then there will be problem. This is not the elasticity, this is the slope of a log-log model. Is it clear? And the slope is not constant over here. This is also very important. Okay, but elasticity is constant. Okay, is it clear? So the beta 2,
Yes, sir.
beta 2 is constant. So this is why it is called constant elasticity model. Now let's see here one example. Y is equal to 2 plus 0.8 ln y. So beta 2 is 0.8. So it means E is equal to 0.8. Right? So it is constant everywhere. This means a 1% increase in x will cause 0.8 percentage increase in y. A 10% increase in x will cause 8% increase in y. Just we have multiplied 10 both the side. Clear?
Sir, I have a doubt. Sir.
I'll come to that. This relationship holds at all points. Now we apply in demand function, production function, especially Cobb-Douglas function, and then income elasticity. Now I will take the question from Madhusmita. So what is my take over here? Let me first conclude the statement and then you will say.
Okay.
Now you just Sangita see over here that in many applications this model is applied, but we don't know actually. We know superficially. Isn't it true?
Yes, sir.
That is the reason even if there are 10 questions, you will miss because you have not clear about the basic. Now you will never forget this. Are you getting my point? If you will
Yes,
read,
sir.
you will never forget. But for that you need to derive. You have to keep patience and again you derive. Then only
Yes,
you will
sir.
be able to understand. Okay, please do that. Yes, now Madhusmita, question our
Sir,
session.
sir, as you say, dy by dx is slope, not constant. So that things I do not understand.
But we have proved that
Yes, sir.
elasticity
Yes.
and slope is getting the same thing over here. That is the reason.
Okay, sir.
We have proved that elasticity is equal to beta 2. But usually beta 2, if you will see in Gujarati book, it is clearly, you are having the Gujarati book, na?
Yes, sir.
Go to it. Go to that book, page, whatever the page you are telling.
Yes, sir.
Chinmay, go to chapter number 6 or chapter number 5, just you check. So,
No,
log linear
here also
model.
I have a book that is chapter number 6.
Ah,
159 paise.
okay. So you just see, there is a clearly it is written that the slope is beta 2 into y by x. So as per the Gujarati book only, we have derived. So that is the reason. So Madhusita, please don't get confused. So this is the
Yes,
slope.
sir. Yes, sir.
Okay.
Yes.
That is why clearly it is written. This slope is not constant. It depends on both x and y. Now you are saying that, sir, why it is so, or why? What was your question?
Sir, actually, I think my question is left hand side dy by dx is not constant or not constant.
It is not constant, na? Because
Yes,
y, because y value will change. So suppose it depends upon x and y, both x and y, na?
yes,
So
sir. Yes,
if x increases, y will increase. The slope will change, na? Here.
yes, sir. Slope will change. Yes, sir.
This is not constant because in linear model it is beta 2. Then the slope is constant.
Yes, sir.
But this is a log linear model, na? Are you getting my
Yes,
point?
yes,
It
sir.
is
Yes,
linear, but log is there.
yes, sir.
Is it Chinmay clear? So,
Yes, sir.
so simply the slope in a log linear model is beta 2 times y by x. But the elasticity is beta 2. But you see, there is a trick to remember. But in a linear model, it is reverse. The slope is, this is the slope, and the elasticity is, what is the elasticity? Madhusida? Just now
Sir,
we had
elasticity
calculated
yes, sir.
beta 2
X,
into x by
X,
y.
X. Yes, sir.
So is there any relation? You just see.
Yes.
Is there any relation? In
No, sir.
there is a relation. Beta 2 is slope, just reverse. But in log linear, beta 2, just you have to remember like this. In log linear model or double log model, log model, beta 2 is elasticity, right?
Yes, sir.
But in linear model, beta 2 refers to the slope only,
Yes,
isn't
sir.
it?
Yes, sir.
And here in linear model, the elasticity is beta 2 times y upon x. But in this model, means log linear model, so it will be beta 2. This is elasticity
by
for the y by x. Means this is actually for the dy by dx, right?
yes,
So the elasticity is basically beta 2. But for linear model, it is beta 2 times x upon y. So there is a reversing logic you can remember, or you can find some tricks to remember. Means beta 2 is different in both the cases. The second model, beta 2 is log linear model, that is elasticity, whereas in linear model, at least you remember this, whereas linear model, it is
slope.
slope. So if you will remember this also, it is fine, because it will come it automatically to your mind that even in linear model beta 2 is only slope, then our elasticity will be x into y, beta 2 times x into y,
Why?
right? Because
Yes, sir.
of the elasticity formula, dy by dx into x upon y. And for log linear model, it is simple, the reverse. Means the elasticity, basically the slope I am talking about, not the elasticity. But the slope is this. So there is a relation. If you will see it, you will feel. Means you will find it. Is it clear now?
Yes, sir. Yes.
But this model is very important, okay? It means we are solving many questions, basically. Is it clear?
Yes, sir.
So now what I want, so I will not go further. So now every one of you, you have to derive this two model and show me your writing, handwriting. How it is done. Okay? Chinmay, what is the elasticity of log linear model?
Log linear model.
Yes.
Beta 2 into
Beta 2 only,
x
na?
upon
Beta 2.
only, sir.
Log linear model is also called double log model, na? Isn't it?
log model.
Log model or double log model, na? Isn't it?
Yes, sir.
Then why again you are confused? Okay. Sangeeta, what is the elasticity for the linear model?
The elasticity for the linear model is
Beta 2
beta 2,
into
sir.
x. No, not
X
beta 2. Beta 2 into x upon y.
beta 2
Yes, sir.
What is the elasticity for log linear model or log model?
beta 2
Beta 2, sir.
Beta 2. Very good. Ajay, what is the slope of a log model?
Log model, sir. Beta 2 into y upon x.
Very good. Then what is the slope of a linear model, Madhusida?
Sir, only beta 2.
Beta 2 only. And what is the speciality about the beta 2 in a log linear model?
Sir, in the log linear model, beta 2 is basically we measure the beta 2, it's measure the elasticity.
Elasticity. Very good.
Yes, sir.
We use in the Kaplan-Glass production function.
Yes, sir.
Right?
Yes.
So in econometrics also it is important because it will make our life easier, because whenever we actually present or interpret in terms of percentage, so that is far better than when we are interpreting in terms of absolute units, isn't it?
Yes.
So always you remember that percentage interpretation is much better than when you say interpretation in unit. So that is the reason it is better that you convert, because it is a economic meaning is underlying meaning is there. Is it clear?
Yes, sir.
So because if I'll teach you much faster, then you will not understand anything. It will go beyond your.
Okay, sir. Many more things will be bounced from.
Uh,
This much is enough, sir. To model is.